Hello, my name is Jordan Carmen, an engineer here at Seaspill. Our mission is to create a system to prevent, detect, and contain oil spills which occur on the ocean. In 2010, the Deepwater Horizon oil spill brought to light how inefficient our methods of mitigating oil spills is, taking 3 months to cap the oil spill which had leaked 3.19 million barrels of oil. In the past decade, there have been 1.7 major oil spills per year. Oil spills occur as a result of human error, equipment failure, natural causes, and even deliberate acts. Each of these oil spills cause pollution which damages animal and plant life. The EPA and Coast Guard are the two organizations in the U.S. responsible for preventing, detecting, and containing oil spills. We researched the current methods they have to see how we can improve them. From this research, we identified our stakeholders, who are very important because they are those who are the clients and those interested or invested in the project. Our stakeholders include oil companies, the Coast Guard, the NOAA, tourists, ocean life, seafood industry, shipping industry, and many more. Once we established our stakeholders, we did further research into what each stakeholder needed from this project. We then translated these needs into technical requirements with our target specifications.
Now we focus on clarifying the exact problem. We divided the problem statement into 3 parts: prevention of the oil spill, detection of the oil spill, and containment of the oil spill. We then focused on our customer requirements and our engineering requirements and used the House of Quality to compare them with our stakeholders. At the bottom, you can see we set a certain amount of targets and how they compare, the existing technologies compare against our met targets. We then focused on patentability. Now, we looked at US patent 9863887. Patentable ideas were like fluorescent oil tracking did come into mind, but oil spills being a global problem, it was better to make the technology open source so that they could be taken care of in the future more efficiently.
So once the different aspects of our design were finalized, we came up with different concepts for each one. So brainstormed a variety of ideas and concepts and narrowed these down to the top 3. One major criteria that we used to narrow these down was their applicability to different types of oil spills, such as oil rig explosions or tanker spills. Once we had these down, we moved on to the Pew matrices and came up with different criteria based on the different requirements and other related aspects related to that system. So for example, in the spill detection, we had the top three ideas that we chose and used our IR and UV sensor as a reference since that was similar to something already in existence and we had very good knowledge of. We then did both quantitative and qualitative analysis, and as you can see on the right there, we determined weights using the analytic hierarchy process, which was based on the different requirements and criteria. And doing so, we were able to find that the fluorescent dye would be the optimal in this case. We did this 2 times for the oil spill prevention and containment as well. So once that was done, we moved on to our FMECA analysis, determine the different risks and dangers that might occur due to some of the aspects of their system failing. Once we did that, we put them into this risk matrix and organized them based on their impact and severity of the damage and the probability of them occurring, so we can identify potential problems of our system that we need to worry about.
So, taking all of those things into consideration, we finally arrived at our final concept. This idea uses a fluorescent dye that's injected into oil as it's being drilled out of the ground. By having this dye present in the oil from the conception of its lifespan, that way we can track it basically at any point in time if the oil occurs or a spill occurs. Using satellite imagery, the fluorescent dye shows up quite visibly throughout the ocean or on land and will allow us to identify the oil spill. Now, moving on to any sort of dealing with a currently existing oil spill, one of our other requirements, we came up with the idea of using dispersants, which would be dropped by an airplane. Now, these dispersants break down the oil spill so that way it's less of an environmental impact once it's already out in the ocean. Finally, using flow sensors installed onto drilling rigs and different pipelines, we can detect any sort of drop in pressure that immediately happens, and then use built-in automatic shutoff valves, which will allow us to stop an oil spill from growing out of proportion. Some of the cost analysis on all that here. So for the fluorescent dye, setup cost will run anywhere between half and almost $1 million. All of that setup is going into piping and storage for fluorescent dye down to the bottom of, for example, an offshore oil rig. These are fairly cheap to run, and also some satellites can be run from CubeSats, so those are also fairly inexpensive to set up. Dispersants can cost anywhere between $500 if you're just buying a tank and then renting planes to use the dispersant, all the way up to around $200,000 if you're going to go out and start acquiring some different various drones or aircraft hangar space. Also, there's going to be a lot of operating cost going into that plane and the pilot. Finally, the flow sensors are relatively cheap to get. You only need either one or two, so $4,500 or $9,000. And those will be installed onto the oil rig or the pipeline when they're initially built, and then stay there for the lifeline of the pipeline or the drill. Finally, some of the lessons learned while we were developing this project. We started off very broad, using lots of arbitrary search terms, using lots of just trying to research that was focused on the whole idea of oil spills and how we can learn anything about them. It probably would have been a little more efficient and beneficial to us as a group had we broken down the problem a little bit more and sort of focused our efforts rather than been so broad with all of our research and understanding of everything initially. However, this ended up helping us later on, as it did end up helping us understand the whole problem together. Also, a lot of Google Drive and GroupMe communication aided at us being very quick with all of our development work. So GroupMe allowed us to schedule things and communicate quickly, and Google Drive, using especially those commenting systems online, allowed us to really give each other feedback and correct things very quickly. Finally, what's next? So the obvious first step would be to make the whole program autonomous. So for example, a machine learning algorithm could be developed to automatically identify fluorescent dye in the satellite pictures that we're receiving 24/7. So that way, rather than having somebody that's actively looking for an oil spill after it happens or that they know of, we can be looking for oil spills 24/7 that we didn't even know, which is something we've never been able to do before. Also, with all programs and all systems, you're going to need iteration to go into the project. So that way, once you see the system is running, let's see how we can improve upon that system and make things run a little bit better. And then finally, all systems are going to need some form of maintenance. Fortunately, this design and this system that we've gone with allows us to get away with not needing a whole lot of maintenance, since most things are going to outlive the system that they're being attached into. So with that, we thank you for watching through our project, and please have a nice day.